Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course. The atomic structure. Today we will begin with lecture 6 from the course, but make sure you have watched the previous ones before viewing this one. In the last lecture, we discussed quite a lot about the number of electrons, protons, and neutrons. And I hope these terms like the isotopes, isobars, etc., they are all clear to you. But now, where did we leave the story of the atom? Yes, we left it at the Rutherford's model. So we will continue our story about the atom from Rutherford, and then in this lecture we would be discussing various developments leading to the Bohr's model of atom, which is the next atomic model that we have to study. And most importantly, in this lecture we would be discussing about electromagnetic waves and electromagnetic spectra. So we will start the lecture with the drawbacks of the Rutherford's model. But before that, quickly revising what did Rutherford say? He said that the atom consists of the nucleus and the extranuclear part. The nucleus is very small as compared to the size of the atom, and whole of the mass and the positive charge is concentrated in the nucleus. And then there are electrons present in the extranuclear part, moving around the nucleus in fixed circular paths called as orbits. And what did he say about the stability of the atom? He said that the electrons are negatively charged. They are having an inward pull because of the electrostatic forces of attraction towards the positively charged nucleus. And then this inward pull is balanced by a force which is acting in the outward direction, and that force is the centrifugal force, which is due to the circular motion of the electrons. And these two forces, they balance each other and prevents the electron falling into the nucleus. Now the centrifugal force is given by the formula mv square by r, and the electrostatic force of attraction is given by the formula K Q1 Q2 by R square, which is equal to ZE square by R square. Okay, so let us understand basically the centrifugal force, how this is mv square by r. You will be able to appreciate when you study this in physics. Similarly, how this formula of the electrostatic force of attraction has come, that is also a part you will be covering in physics. But understanding what this means. M over here is the mass of the electron, V is the velocity of the electron, and R is the radius of the circular orbit. For the electrostatic force of attraction, Q1 and Q2 are the charges, and R square is going to be the square of the distance between these two charges, and K is the proportionality constant. Now putting this into the concept of the atom, we have ZE multiplied by E by R square. Z is the atomic number, E is the charge on the proton, which is equal to the charge on the electron numerically, right? So we have ZE, the charge on the proton, and then multiplied by the other E, which is the charge on the electron. So these two become the charges on the protons and the electrons, and r square is going to be the radius of the circular orbit, and that is the distance between both of them. So I hope this formula is clear to you. Where has this z come from and what is basically this meaning? Now everything was fine because the centrifugal force was balancing the electrostatic force of attraction, and the nucleus and the atom, this was basically stable as a whole. But the problem came when Maxwell gave his electromagnetic theory. And according to his theory, a charged accelerated particle loses energy constantly, and because the electron is a charged particle and it is in acceleration due to circular motion, so it must emit radiation. such that its orbit becomes smaller constantly and ultimately falling into the nucleus. So let us understand this also with a diagram. Basically, what Maxwell said was that a charged accelerated particle loses energy. Now the electron, is negatively charged. It is moving in a circular path, although its speed is uniform, but at every instant its direction is changing because it is moving on a circular path, right? So we can say that electron is a charged accelerated particle, and according to Maxwell, it has to lose energy. This energy it loses in the form of electromagnetic radiation, and now as it is losing energy, its energy is becoming less, so it slow and steadily loses energy, and ultimately this is going to fall into the nucleus. And calculations show that it should take an electron only 10 power minus 8 seconds to spiral into the nucleus. But this does not happen. So the Rutherford model, because it could not explain this, it could not explain the stability of the atom, and hence this is an important drawback of the Rutherford's model. And then the Rutherford model could not explain the distribution of electrons. That is, it does not tell anything about the arrangement and the energy of electrons around the nucleus. So these are basically the drawbacks of the Rutherford model. And then the Maxwell theory and many other theories came, which led to the development of the next atomic model we are going to study. So the next atomic model we have to study is the BOHR'S model of the atom, and what all developments led to this study, to this model, we are going to study in the subsequent lectures. So starting off, that there were many studies regarding the interaction of radiations with matter, which provided immense information and indication regarding the structure of atom and molecules. And Niels Bohr was the one who utilized these results to improve upon the model given by Rutherford. And two major developments which he considered while formulating his model were: first, that the electromagnetic radiation, it has dual character, that is, the radiations have both wave-like and particle-like properties. And the next is that there were experimental studies in relation to the atomic spectra, suggesting that the electronic energy levels in atoms are quantized. So basically, these are the two major developments which we are going to study slow and steadily. We will start first of all with what are basically electromagnetic radiations. To understand what are electromagnetic waves or electromagnetic radiations, first we should understand what is the definition of a radiation. A radiation is the mode of transfer of energy of different forms, and the energy transmitted from one body to another in the form of rays or radiations is called as radiant energy. One very simple and daily everyday life example is the sun's energy, which we are receiving from the sun in the form of rays or radiations. Other examples of the radiations can be cosmic rays, X-rays, ultraviolet rays, visible light, heat, and light, which was once supposed to be made up of particulate nature called as corpuscula. This was given by Newton. This was rediscovered as being of electromagnetic nature by Maxwell. Maxwell proposed that the radiant energy has wave character, and these waves, they are associated with electric as well as magnetic fields. Thus, these radiations are called as electromagnetic radiations. And what are the sources of these electromagnetic radiations? First source are the heated objects. Objects at very high temperature, they emit radiations called as thermal radiations. which consist of electromagnetic waves of various frequencies or wavelengths. And then the second source is the electrically charged particles moving under acceleration, just like we saw in the case of electron. So James Maxwell was the person who suggested that when electrically charged particles they move under acceleration, alternating electrical and magnetic fields are produced and transmitted in the form of waves. And these waves we called as the electromagnetic waves because they are in the form of waves, they are having electrical as well as magnetic fields. So hence the electromagnetic waves or the electromagnetic radiation, because these are radiations being transmitted in the forms of waves. So I hope the definition of the electromagnetic waves or the electromagnetic radiation is clear to you all. So now the characteristics of the electromagnetic waves. The first is that the oscillating electric and magnetic fields produced by the oscillating charged particles, they are perpendicular to each other and both are perpendicular to the direction of the propagation of the wave. So if the wave is propagating in this direction, let it be x axis, so the magnetic and the electric fields, they are going to be produced by this charged particle, and this electric and magnetic fields, they are perpendicular to each other and also perpendicular to the direction of the propagation of the wave, right? So the next is that unlike the sound waves or the mechanical waves which are produced in water, the electromagnetic waves do not require any medium to travel. They can travel in vacuum. And there are many types of electromagnetic radiations which differ from one another in wavelength or frequency, and these constitute the electromagnetic spectrum, which we will just study in a short while. So now, according to Maxwell, the electromagnetic radiations, they have wave nature. In fact, they have a transverse wave character. So the waves, they can be classified as longitudinal and transverse waves, which probably you have studied about in class 9th and 10th, and you will be discussing more in class 11th in physics, right? So basically, if you will see, the electromagnetic waves, they are similar to the transverse waves. And what happens in a transverse wave is that if we have supposedly a source of vibrations at the point where my cursor is, the source of vibration, the oscillations, they are going to be, for example, in the up and down direction from this mean position. And then the direction of the propagation of the wave energy, this is going to be perpendicular to the direction of these oscillatory movements, right? This is basically similar to a thread. If you tie it to one end of and the other you are holding in your hand, and if you move your hand up and down, what is going to be the movement of that thread? It is going to be basically this, right? So these are the waves which have been created by the movement of the hand up and down. The particles, they are moving in up and down direction. The direction of the wave is perpendicular. Okay, so this is what is a transverse wave. And if you understand from this direct, what the positive part, the one above the mean position, this is called as the crest, and the part of the wave which is below the mean position, the negative displacement, that is called the trough. And the maximum point of displacement of the crest, the center of the crest, this is called as the amplitude. Similarly, the maximum displacement below the mean position, the negative displacement of the wave, this is the center of the trough. So this is also the amplitude. Okay, so what is amplitude? The maximum displacement of the wave, either in the positive direction or the negative direction from the mean. This is going to be the amplitude. And then what is wavelength? Basically, wavelength is the distance from one crest to the other. or we can say one trough to the other, or this is going to be basically the distance of the wave in one cycle. What does one cycle mean? Say if one point we have this, right? So the similar position of this point would be at where? This is going to be here. So as this particle, the same, this is going to follow this curve. So the particle at this point, this is going to follow this same curve. So the distance from one point on the mean position to the other point alternate. Okay, so we will not consider this to be one wavelength. So this whole one crest and one trough, the whole length, this is called as one wavelength or one cycle of the wave, one oscillation of the wave. So let us understand what are the parameters of these electromagnetic waves. They are exactly similar to what we will describe for the transverse waves in physics. So wavelength is the distance between two consecutive crests or troughs in a particular wave. Since it is a measurement of length, so it is measured in Armstrong unit, where 1 Armstrong is 10 power minus 10 meter, or 1 nanometer, where 1 nanometer is 10 power minus 9 meter, that is 10 Armstrongs. And the wavelength of the visible light determines its color. The white light, the visible region of the electromagnetic spectrum, this is a combination of 7 different radiations with the wavelength from 400 to 750 nanometer. So you remember in the small classes you've studied that white light is composed of 7 colors. So basically this white light is composed of 7 different type of radiations which have different wavelengths, and the wavelengths are ranging from 400 to 750 nanometer. Next we have is the frequency. So for frequency, take any point on the path of the wave. For example, we take this point, okay, or this point. If we take this point and we count how many waves, complete waves, they are passing through this point in 1 second, that is going to be the frequency. So this is the number of waves or cycles. Cycles mean one complete wave, okay. So one complete wave from this to this, right? So this is one complete wave. So the number of complete waves or cycles which pass a given point in 1 second is called as frequency. This is represented as cycles per second, that is second inverse, or in hertz short form it is written as Hz. The wavelength, please do remember, this is denoted by this symbol which is called as lambda, and the frequency by this symbol which is called as nu, nu. Okay. Now what is basically the relationship between wavelength and frequency? So if a wave has a long wavelength, so the number of waves passing one point in a second is going to be less. And if a wave has a small wavelength, so then the number of waves passing through a particular point is going to be more. So this means that the wavelength and frequency, they are inversely proportional to each other, right? So if I have a point this where the cursor is, if at this point the number of waves passing is more, that means that the length of that wave is very small, right? The wavelength is less. Next we have the time period t. So the time period of the wave, that is the time taken by a wave to complete one oscillation, and this is inversely proportional to the frequency. Why so? Because time of the wave is basically time taken by the wave to travel a distance equal to one wavelength. So if the wavelength is more, then the time period is going to be more, and the number of vibrations, the frequency of that wave is going to be less, right? So that is why time is inversely proportional to frequency. Next we have is the velocity. So velocity is the linear distance traveled by a wave in 1 second. You all know what is velocity and the units are meter per second. And then we have wave number, which is nu bar, and this is the reciprocal of the wavelength, and it is defined as the number of waves per meter. So in 1 meter, how many waves are present? That is called as the wave number, and this is expressed in meter inverse. And nu bar, the wave number, is inversely proportional to wavelengths, hence 1 by lambda. And amplitude, we've already discussed that this is the maximum height of the crest or the trough of a wave. And now a very important relationship between the velocity, wavelength and frequency. So we've already discussed that the frequency is inversely proportional to the wavelength. So we can say that the frequency nu is equal to C 1 by lambda, or C is equal to nu lambda, where C is a constant. And what is the C? Basically, in vacuum, we've all studied that all types of electromagnetic radiations, regardless of the wavelength, they travel at the same speed, that is the speed of light. And this is equal to 3 into 10 power 8 meter per second. To be precise, it is 2.99795 into 10 power 8 meter per second. For calculation purposes, we are going to use 3 into 10 power 8 meter per second only. Right? So this is basically the relationship between the velocity, the wavelength and the frequency. Right? So for the electromagnetic radiations, you can always remember that the velocity is the velocity of light, that is 3 into 10 power 8 meter per second. So the next topic of discussion for today is the electromagnetic spectrum. What is electromagnetic spectrum? It is basically the arrangement obtained by arranging different types of electromagnetic radiations in their increasing or decreasing order of wavelengths or frequencies. So the order is in front of you. Basically, it is the gamma rays, the X-rays, the UV rays, the visible rays, IR, the infrared rays, the microwaves and radio waves, and these have been arranged in the decreasing order of frequency or the increasing order of the wavelength. So you can see it in the diagram below also. We have the frequencies written. So the long radio waves moving to different categories of the radio waves, the AM waves, the FM waves, then the microwave rays, the infrared rays, UV, X-ray and the gamma rays. So basically they have been arranged in the order of the if you start from the gamma rays, the maximum frequency, going to the radio waves with the minimum frequency, and this is inversely proportional to the wavelength. So the wavelengths of the gamma rays is the least and that of the radio waves is the maximum. And also one point please do remember here is that the frequency and energy, they are directly related to each other. So the energy of these radiations, they are going to follow the order of the frequencies. So the gamma rays, they are going to have the maximum energy. The radio waves, they are going to have the minimum energy. And now this colored portion in between, this is the visible spectrum, the VIBGYOR, if you remember from your junior classes. So VIBGYOR is what? The violet, the indigo, the blue, green, yellow, orange and red. These are the visible radiations, visible colors which you see, and they have been arranged according to the wavelength. The violet having the least wavelength, going on towards the red side, which is having the maximum wavelength and the least frequency. So right, I hope this is all clear to you all, and you are required to learn the range of these frequencies and the wavelengths. These are important and sometimes they are asked in the examinations. So some sources of the electromagnetic radiations. First are the radio waves. The frequency is approximately 10 past 6 Hertz. They are generated from the alternating currents of high frequencies and they are used for broadcasting. Then we have the microwaves. The frequency 10 past 10 Hertz and they are produced from special generators, for example, klystron tube used in telephone, radars and in ovens for heating food. So you all know the microwave oven which we use at home so frequently. And then the infrared radiations, the frequency approximately 10 past 13 Hertz, they are used in physiotherapy. A plot of frequencies of infrared radiations versus the intensity of radiations absorbed is called as the infrared spectrum. And this is used to identify a substance because each substance has its own characteristic infrared spectrum.
Then next we have the visible light radiations, and these are the radiations which you are known with so well. You can see all sorts of different colors, the visible light. So the frequency of the light radiations being 3.95 into 10 power 14 Hertz to 7.9 into 10 power 14 Hertz. And how are these produced? They are produced from stars, the sun, lamp, hot filaments of the bulb, the tubes and so forth. And then we have the UV radiations, the frequency ranging of the order 10 past 16 Hertz present in the sun rays produced in the labs from arc lamps containing mercury vapor, xenon or hydrogen gas. X-rays, frequency of the order 10 power 19 Hertz produced when a stream of electrons strike a heavy metal target. They are used in medical diagnosis and I hope you all know that we do get our X-rays done when we have some fracture or things like that. And then the gamma rays, the frequency 10 power 20 Hertz, the maximum we have for the electromagnetic radiations known to us till date, and then they are having the maximum energy, the least wavelength. They are emitted from the radioactive substances and they are used in radiotherapy. So I hope all these electromagnetic radiations, you understand what is the spectrum. You are supposed to learn the frequencies and the wavelengths of these. Many a times they are asked in the questions, so please do learn them. So I hope the electromagnetic radiations, they are clear to you. What is the definition? What are the characteristics? What are the parameters of these radiations? And now that you know that the electromagnetic radiations, they have a wave nature, can we demonstrate that these have a wave nature? Yes, we can. We can do this by two phenomena. One is diffraction and the other is interference. And all sorts of waves, be it water waves, the sound waves or the light waves or any other electromagnetic wave, they all are going to show this phenomena. And that is how we come to know that these radiations, they have a wave nature. So what is first of all diffraction? Diffraction is the property of waves to bend around obstacles in their path of propagation. So what do I mean by that? You all know that light travels in straight lines, right? So if we place an obstacle in the path of light, what happens? A shadow is created, right? But now what happens is, if you see very carefully, the shadow, the margins of the shadow, they are not very sharp. Why they are not sharp is because light from the other areas have entered that margin. Why has it entered? It is entered because at the margin of the obstacle, there has been bending of light. Why is the bending of light? Because light is not traveling in straight lines. Basically, light is traveling in the form of waves. And some portion of the light diffuses into the dark area, making the margin of the shadow not very sharp, right? So that is the property of diffraction. And then we have interference. So what do I mean by interference? You can imagine it basically like if we have two people, they cannot occupy the same space at the same time. No two solid objects can occupy the same space at the same time. But waves, they can overlap. They are basically just disturbances of the matter, right? So they can overlap, they can combine with each other, and this is the phenomenon of superimposition of the waves. So when two waves, they come near each other, they overlap, they produce a interference pattern. So what do I mean by interference? That they interfere with each other and produce a completely new pattern. So this you can see in the water waves, but this is applicable to the sound waves also and the light waves also. So let us see what is the definition of interference. This is the combination of two waves of the same or different frequencies, right? So we have a combination of two waves. They may be of the same frequency, they may be of a different frequency. They resultant is that there is the superimposition of those two waves, and they give a wave whose distribution at each point in space is the algebraic or the vector sum of the disturbances at that point resulting from each interfering wave. So let us understand the second part, what we have seen. So we have a wave X and a wave Y. They both are combining with each other. So now if the crests of the wave X, they are similar to the crests of the wave Y, what happens is that you can say that the amplitude of this wave X is A and that of the wave Y is also A. So what will happen is that these crests, they are going to overlap with each other, the troughs are going to overlap with each other, and the resultant wave formed is the vector sum of these two waves, okay? And the resultant wave, what will the amplitude of this be? That would be 2A. Right? And such a pattern which is formed by these two waves resulting. So the amplitude is greater than the amplitude of the two waves. Such we call is as the constructive interference. But now what can happen is that the crest of the first wave can be overlapping with the trough of the other wave. So this amplitude is A and this amplitude is minus A. So the vector sum is going to be what? A plus minus A, that is going to be 0. So that is why we see that we have nothing over here. There is no wave being produced because the amplitude of the wave is 0. They have cancelled each other, and that is what we call as destructive interference, where the amplitude of the resultant wave is less than the amplitude of either of the waves, okay? So this is the basically extreme case when we see 0 amplitude. There can be somewhat a little wave of a less amplitude, whatever the interaction is. So what is interference is the combination of two waves producing another wave having a different interaction pattern, and the resultant wave produces the algebraic or vector sum of those two waves. So I hope the both terms, they are clear to you. What is diffraction, what is interference? You will be understanding them more when you study in physics. For me, basically, you have to understand that the electromagnetic waves, they are basically having a wave nature. The radiations, they have a wave nature, and this is shown by two phenomena, the diffraction and the interference. So now let us do one or two numericals based on the frequency and wavelength relationship that we have done. We have done that frequency is equal to C by lambda. So the numerical one says that yellow light emitted from a sodium lamp has wavelength of 580 nanometer. You have to calculate the frequency and the wave number. So we have lambda to be 580 nanometer, that is 580 into 10 power minus 9 meter. Or if you write it proper scientific notation, that is 5.8 into 10 power minus 7 meter. Then we know that C is equal to nu lambda, or nu is equal to C by lambda. So you can calculate the frequency by putting the value of C to be 3 into 10 power 8 meter per second, and the wavelength is given to you 5.8 into 10 power minus 7 meter. You get the frequency as 5.17 into 10 power 14 second inverse, and the wave number, that is the inverse of the wavelength, 1 by lambda. So wave number nu bar is 1 by 5.8 into 10 power minus 7 meter, and this you get as 1.72 into 10 power 6 meter inverse. The second numerical says that the Vivid Bharati station of All India Radio Delhi broadcasts on a frequency of 1368 kHz. Calculate the wavelength of the electromagnetic radiation emitted by the transmitter. Which part of the electromagnetic spectrum does it belong to? Okay, so this is basically a radio station. So this electromagnetic radiations we are talking about are the radio waves, right? So this is one thing which we can understand from the question also. Then we are given the frequency of the waves to be 368 kilohertz. So if you convert it into the SI notation, this is going to be 1.368 into 10 power 6 second inverse, or hertz also. Okay, so we have the frequency, you know the relation, it is frequency is equal to C by lambda, or we can say that lambda is equal to C by nu. So we get lambda to be 3 into 10 power 8 meter per second divided by 1.368 into 10 power 6 second inverse, and you get the wavelength to be 219.3 meter. Now if you remember the electromagnetic spectrum chart, you will be able to tell what is the region of the spectrum of this wavelength. So you can check it from there, but you have to learn it also that the frequency and the wavelength of these waves, this is the characteristic of the AM region of the radio waves, right?
So now we have the Havanite section for you. So the EM waves, please do remember, they do not possess any mass or any charge. They are massless, they do not have any charge. And they are cosmic rays. So rays, they are having basically the frequency of the order 3 into 10 power 20 hertz to infinity. These originate from the outer space, continuously fall on Earth due to their extreme penetrating power. They were once considered to be the electromagnetic waves because they are rays. So we think that they are EM waves, but actually the cosmic rays are now discovered to be of particulate nature. They are not EM waves, and they are composed of subatomic particles like protons, nucleus of atoms, and other subatomic particles, and they travel with a speed less than that of light. The EM waves, they are traveling with the speed of light. They do not consist of particulate nature, so the cosmic rays are not EM waves. So please do remember this. So that would be all for this lecture. I hope you're all clear with the electromagnetic radiations and the electromagnetic spectrum. In the next lecture, we would be discussing the Planck's quantum theory. And if you are having any query, any difficulty, please do mail us at h2ochemistry@gmail.com. And if you've liked the lecture, please do click on the like link, and also do subscribe to our channel H2O, and click on the bell icon to get a notification as and when we put up a new lecture for you, a new course for you. So bye for now from the channel H2O. See you again in the next lecture. Bye bye. Thank you.